So, hello everybody. Today I would like to test a tool for CFD simulation, CfdOF. CfdOF is a workbench for FreeCAD. Based on OpenFOAM, this workbench is helpful to use OpenFOAM with a FreeCAD modeler. Future were steady and transient simulation, single and multiphase, incompressible and compressible fluid, laminar flow, turbulent flow, basic material database, high-speed compressible flow is possible to simulation. Solver is OpenFOAM and post-processing is ParaView. First step, install FreeCAD. And after this you can start add-on manager for external workbenches. Okay. Here is CfdOF. It is already installed on me. I only show the necessary steps. After installation, FreeCAD and CfdOF, go to the menu Edit and select Preferences. In Preferences, you can see CfdOF and installed OpenFOAM, ParaView, CF Mesh and High Speed. The software is now ready to simulate CFD, but before I start with simulation, it is helpful to calculate a simple analytical example. I am absolutely beginner in CFD analysis. I need any checks. Analytical example, a simple pipe with flowing fluid. There is a pressure loss between 2 points in fluid. Pressure 1 is bigger than pressure 2. Example data, pipe diameter, pipe length, fluid density, dynamic viscosity and volume flow 5 cubic meter per hour. Formula 1 is for pressure loss. U is flow velocity. Formula 2, for velocity is necessary a pipe cross section. It is formula 3. In this example, pipe is smooth. Roughness is 0, so that the friction coefficient lambda is dependent only on Reynolds number. Some correlations for lambda exist. Formula 4.1 is Blasius correlation, or 4.2 is correlation of Nukaridze. Formula 5 is for Reynolds number with pipe diameter, flow velocity and kinematic viscosity. If Reynolds number is greater than 2900, then its flow is turbulent. 6 is kinematic viscosity. For pipe roughness 0, we can use formula 4.1 or 4.2, depending on Reynolds number. If pipe should be calculated with roughness, you can use formula 4.3. Here is no friction coefficients, dependent on Reynolds number and absolutely roughness curve. Calculation. The pipe cross-section is calculated first from 3, after T is flow velocity 2, und kinematic velocity 6. Reynolds number from Formula 5 is bigger than 2900, so is the flow turbulent, and for friction coefficients 4.2. All the results in Formula 1. So pressure loss is 61,801 Pascal. If right side of the pipe is open, then is pressure 2 is 0 and pressure 1 is 61,801 Pascal. By incompressible problems, OpenFOAM solves transform static pressure to kinematic pressure. Static pressure divided by density. It is formula 7. Now simulation will start and compare the results. We go back to FreeCAD. Create a new model. Go to Sketcher and create new sketch. Pipe diameter is 10 mm. Then change in part modus and extrude sketch. You can create simple geometries directly. For example, cylinder, spheres, cubes. So CAD model is ready. Go to CfdOF workbench. First, we create an analysis container for CFD. In analysis container, we define physics model, steady analysis, single phase, and turbulence. After that it is fluid selected from material database. Water. Next is initialize flow field, velocity and pressure potential flow. The defined fluid boundaries inlet with velocity in z direction, outlet is open, pressureless, and wall no slip, so viscose. Next step is to create a mesh with base element size 0.7 mm, so global mesh. Run measure. Mesh is finished. Solver can now be started. Simulation was successful. Let's look at the results with PowerView. Results of velocity, pressure drops. Let's create a line plot. show probe results on point pressure 1 and 2. Kinematic pressure is 61.9. It agrees well with analytical results. I did another comparison results depending of element size with 0.7, 1 and 2 mm. Here in the table you can see how important mesh is. For any tips or critique you are welcome. Bye.